This video will cover page 5.2 notes, so I'll show back up to 5.1 so you remember what we're doing here. We are graphing two lines and figuring out where they intersect, or if they're parallel, or if they end up being the same line. So as you'll see, when we start with number 3, you are going to have to do step 1 to get y by itself. So if we look at the top equation, I'm going to just rewrite it. Negative 3x plus y equals 8. So to get y by itself, I would have to add 3x to both sides. So those go away. Y equals 3x plus 8. Now I can find my y-intercept and my slope. So I start with going up 8. And then normally I would go up 3 and right 1, but that would take me off the graph, so I need to go down 3 and left 1. And again, you can put as many dots as you want. I like to put a lot of them on there so I can find where my lines cross. Carefully draw your line with a ruler. And put your arrows on the end. Now the bottom one, you have two different ways that you can graph this. So if I rewrite it, you can do exactly what you did up above, which is add x to both sides. And we get y equals x plus 2. So for that, we start up 2, and then up 1, right 1, down 1, left 1. I'm going to keep going until I find the spot right there. So it intersected at negative 3, 1. Negative 3, negative 1. When you check your answer, so to plug it back in, you'll want to plug it back into the original one, just in case you solved something incorrectly down below. So negative 3 times negative 3 is 9, plus negative 1 does give me 8, so it works in the top one. A negative 3 means positive 3, plus negative 1 does give me negative 2. So you know you did that one correctly also. I said there were two ways you could have graphed the bottom one, so let me go through that again. Squeeze it over here. Negative x plus y equals 2. Actually, let me write this in a different color. Negative x plus y equals 2. You could also find your x and y intercepts. So remember, for that we do negative x equals 2, so x would equal negative 2. And then your y-intercept is just y equals 2. You cover up the y to get the x-intercept. You cover up the x to get the y-intercept. So if you look at my graph, x-intercept was negative 2, y-intercept was positive 2, and you could connect those. So when you have equations that are in standard form, you can always solve them for y. So if you don't want to worry about the x and y-intercepts, that's totally fine. You don't need to use them. You can use them, though, if your coefficients, so you have a negative 1 and a positive 1, can go into negative 2. So that's why I could use it there. I couldn't use it on the top one because 3 does not go into 8. So again, you do not have to use the intercepts, but you can if you want to. All right, if you look at the top one of number 4, you could use the intercept. So I'm going to do that first in case you want to do that. X equals 4. So again, the first thing you do when you find your intercepts, we're going to just make that go away. Okay, x equals 4. You're covering up the y. Then for the y-intercept, you cover up the x. So if we get rid of the x, it says 2y equals 4. So we divide and we get y equals 2. So your intercept of x equals 4 would be right 4, and you put it on the x-axis. y equals positive 2 would go there, and that is what you would graph. Right? If you would rather solve it, it would look like this. Move the x first, so I subtract x. 2y equals negative x plus 4. You want to write your x first so that it's in slope-intercept form. Divide everything by 2. We get y equals, if there's nothing there, you can put a 1, so negative 1/2 x plus 2. When you solve that, you'll notice it's the exact same as the bottom one. All right, you do still have to show that you graphed it. So if you graphed it like this, up 2, down 1, right 2, you could also go up and left, but you are graphing the same equation twice. So what that means is our solution is an infinite solution. So you can write the infinity sign. So again, up in the top, you can either solve for y. That will work every time. So if you don't want to worry about the intercepts, don't. You can solve for y every time and then graph it with slope-intercept form. If we look at number 5, I noticed that I can't use intercepts. I would be able to, but the x-intercept is negative 15, so that would not fit on my graph. So I do have to solve it. So again, you always move the x term first. So in this case, we're going to subtract x. 3y equals negative x minus 15. Divide by 3. Y equals negative 1/3 x minus 5. So when I graph this, I start down 5. And then down 1, right 3. I can go up 1 and left 3. Again, just draw your line as carefully as possible with your ruler, or you could put lots of dots in if that's helpful. Our bottom equation is one you're going to just have to remember. If you have both an x and a y in your equation, like we have for all of them, you should have a slanted line. Now we have just y equals a number. So if you think about y equals negative 7, that would be down 7. So I would put it there. There is no slope. Your slope is 0 because it made the x go away. So you don't just leave a dot. All of these need to be lines, so you draw your line straight across to get a slope of 0. So y equals a number is a horizontal line. So our solution would have an x value of 6 and a y value of negative 7. It should make sense that you have to have a y value of negative 7 since that was one of your equations. Number 6, your top one is already in slope-intercept form, so I start up 5 and then a slope of 1/1. So up 1, right 1, down 1, left 1. For the bottom equation, you can do your intercepts, so I'll show you that first. Again, for your x-intercept, you just cover up the y, and it says x equals 2, so that one's done already. The y one is a little bit trickier. If you cover up x, you have to be really careful, and it says negative y, or the opposite of y, is equal to 2. We don't want to know what opposite of y is. We want to know what y is. So it's like dividing by a negative 1. So y would be negative 2. So when I graph those, x is positive 2. It's the x-intercept, so on the x-axis, and y is negative 2. So right now, it looks like my lines are not going to cross. If you wanted to solve for y instead of using your intercepts, again, that will always work. X minus y equals 2. So you would subtract x to move it over. the opposite of y equals the opposite of x plus 2. This is like having a negative 1 in front of the y, so we need to divide everything by negative 1, giving us y equals positive x plus 2. Sorry, minus 2. So you can see that's exactly what I have graphed. So we do know that these indeed are parallel because they have the same slope. Same slopes is going to be parallel as long as they have different y-intercepts. If they have the same y-intercept, like we did in number 2 up here, or sorry, up in number 4, then it's the exact same line. So this one would be no solution, so you can put a 0 with a slash through it, or you can write out no solutions. For number 7, for the top one, you will have to solve for y. I'm going to rewrite it. So first we need to move the x over, so subtract 3x. Negative 5y equals negative 3x minus 35. Divide everything by negative 5. Y equals, just leave that as positive 3/5 x plus 7. You have a negative 35 divided by a negative 5. So to graph that, I start up 7. Normally, or we can go up 3 and right 5. Can also go down 3 and left 5. The bottom one, you can use intercepts or you could solve it. If you use intercepts, you would get 2x equals negative 6. So x equals negative 3. And then when you cover up the x, you just get y equals negative 6. So if I graph that, x equals negative 3 and y equals negative 6. All right, you also could solve that one for y. That would be an easy one to solve for y. You would just subtract the 2x, giving me y equals negative 2x minus 6. So when I graph that, either by finding the intercepts or by solving for y, that would be where they connect. Negative 5, positive 4. Again, you can plug those into your equations up above to check them to make sure they are correct. And finally, number 8. I'm going to start with the top one, x equals negative 2. So x equals negative 2 means I go left 2, and then I draw straight up and down. X equals is a vertical line. You can use intercepts for the bottom one. So if I cover up the y, it would say 3x equals negative 18. So I divide and get x equals negative 6. If I cover up the x, it says negative 2y equals negative 18. So y would equal positive 9. So x equals negative 6. Y equals positive 9. The only bad part about that one is it's going to be hard to tell where exactly it crosses, so you might want to solve it instead. So I'll show you that. So you would subtract 3x from both sides. Negative 2y equals negative 3x minus 18. Divide everything by negative 2, and we get y equals positive 3/2 x plus 9. So we know the plus 9 is correct. Instead of going up and right, we can go down